Well, math analysis students, it's 5:10 on a Friday afternoon, and I'm still at school making a video for you for your homework. So, yeah, there's that. Okay, now we're going to get into some properties of logarithms, and today I'm just going to kind of go over with this video the three main properties you need, which are right here, and how to use them in a few examples. So the video will probably take about 10 minutes. I'm going to try to squeeze in 4 examples, maybe just get to 3. All right. The first example, and these examples are for you on the e-board. They're on the same calendar tab as the video is. The first example is pretty challenging, but I like it because it incorporates 2 of these rules. The first 2. All right. And what the rules really say, I mean, like exponent expressions have properties, log expressions have properties too. All right, so where you have kind of like how when you multiply exponents, you with the same base, you add the exponents. When you're adding logarithms, because a logarithm really is an exponent, when you're adding logarithms, there's some aspect of multiplication that's really going on. You're multiplying the arguments, okay, to condense to a single logarithm. So log x doesn't matter the base; it could be log base 2, as long as the bases are the same. Log x plus log z is going to equal log of the product xz. So log 2 plus log 3 is log 6. Log a squared plus log a to the third is log a to the fifth. You're multiplying the arguments when you condense to a single logarithm. Right? Log x minus log z is log of the argument x over z. It's not log x divided by log z. That's something different. We've done that when we had to solve for the exponent in those interest rate problems. We divided logarithms. You're not doing that here. It's different. When you subtract logarithms, you condense to a single logarithm by dividing only the arguments. Okay? Log 10 minus log 2 is log 5. Log x to the third minus log x squared is log x, because x cubed divided by x squared is just x, and so on. And last, we have a rule here that really just says that the exponent of the argument can be moved in front of the logarithm to become the coefficient, okay, and vice versa. So log x to the third is the same as 3 log x, all right? Now we're going to use actually all 3 of these properties in this example, all right? Now this is kind of an aggressive example, but you want to start with the parentheses. In this case, this guy plus this guy. And you want to condense that to a single logarithm first, and then we'll go from there. By the way, the instructions for this problem, like it says on the e-board, it says write the following as a single logarithm with a coefficient of 1, all right? So we'll start inside here, log a to the 4th plus this guy. I'm going to start by, I'm going to use blue, and I'm going to leave log a to the 4th. You want a coefficient of 1. You could bring the 4 in front and make it 4 log a, but you want a coefficient of 1, so we're going to leave that there. Plus, now, I'm going to change this to a coefficient of 1 by bringing the 3 up here, meaning we're going to raise this expression to the 3rd power. All right, so you can do that. That's using this rule backwards. Instead of 3 log y to whatever, it's log y to whatever to the 3rd. All right, so we're raising the argument to that 3rd power. The argument here happens to be y to the negative 2/3. So we've got to raise y to the negative 2/3 to the 3rd power, and that becomes, well, negative 2/3 times 3 is negative 2. So we get this. All right, so all I've done is I've raised, instead of the 3 here, I brought that as the exponent on the argument. And minus 5 log z. Actually, in one step, let's move the 5 up there. Because again, we know we're going to need a coefficient of 1 eventually. So I just brought the 5. I raised z to that 5th power. All right? So that would be my first move. Now I'm going to keep condensing inside here. Because we have addition, I'm going to use that first property and say, all right, well, this just becomes log a to the 4th y to the negative 2nd. Okay? Log this plus log that is log of the product. All right? And now, I guess we don't need the parentheses anymore. Right? Because there's nothing to distribute. Minus log z to the 5th. Okay. Next step, I'm going to bring this coefficient, because it's 2 times this, I'm going to raise the entire argument to that power now. So we have log a to the 4th y to the negative 2nd to the 2nd minus log z to the 5th. And this becomes log a to the 8th y to the negative 4th minus log z to the fifth. And last, I'm going to use the middle property. Log x minus log z is log of the quotient, right? So a single logarithm, and the quotient's going to be this times this. So a to the eighth, y to the negative fourth, over z to the fifth. And when we subtract, we divide the arguments. We have the logarithm of this, not log divided by log. People have made that mistake in the past, okay? You just divide the arguments. And now, guys, because we never leave negative exponents in the answer, as you know from the previous unit on exponents, we can just bring that y to the fourth to the denominator. We get y to the fourth, z to the fifth down there, and a to the eighth up there. Okay, and that's the final answer. So that's the work. This is a very hard problem in the grand scheme of things. Most of the problems are much easier, like the ones I just said kind of quickly, like what is log 2 plus log 7? Well, log 14. Or what is log 12 minus log 4? Well, it's log 3. But I thought I'd go over a pretty aggressive example to kind of to start, just to show you how all the different properties can work together. All right. Generally, when you're asked to condense to a single logarithm, the first line of business is to get the coefficients into the exponent. Okay. You want to bring the coefficients into the exponent and then apply some of these rules to condense this to a single logarithm. The logarithm of a single argument. All right. Let's see how much time I got. 6 minutes. I'm doing fine. All right. Next example. This is going to be much, much faster. Log 4 root xy. I'm just speaking right now to save some dead air. Hope you guys all are having a nice weekend. I'm about to go to the Players Show in like 30 minutes. I'm very excited. Going to be in my first Players Show ever. We'll see how that turns out. All right. Example 2. Okay, it says expand the following logarithm, leaving no exponents. Well, there are no exponents here, but if there were, that would be important to keep in mind. All right, so it says expand this. So when you're expanding, that's when you want to write your answer sort of like it is on the left-hand side. This is the expanded version of this. Log xz, it's like log x plus log z. That's how expanded means with logarithms. All right? So the first line of business is to probably think about when you, it's a very simple technique here, but when you square root a product, that is like, what I would probably write this as is instead of 4 root xy, 4 times root x times root y. So you have every factor separate, because every different factor in the argument is going to get its own logarithm. That's how you want to fully expand this. And when you do that, every single factor in the argument gets its own logarithm. All right? So next, because it's all being multiplied, there's no division, so we won't use any subtraction. We won't use this middle rule at all, but we'll use the top rule. All right? Log 4 plus log root x plus log root y. Now, another thing that the instructions said, actually it didn't say it on here, but I usually write this. This is my mistake for not writing it. It should say leaving no exponents or radicals, okay? A radical is really like an exponent, so they kind of go hand in hand. All right, so we've got to take care of this. We have plus log x to the 1/2, right? Root x is like x to the 1/2. Root y is like y to the 1/2. So you didn't really need to show this step. If you knew this exponent was 1/2, then you could just go right from here to what will be my final step, all right? Leaving no exponents or radicals. We have log 4 plus the last rule. We can move the exponent in front. 1/2 log x plus 1/2 log y. Okay? So that's the final answer. And again, you didn't have to write this step right here. But I would definitely recommend the first step, breaking up everything into separate factors. And then you'll see, okay, every factor gets its own logarithm, right? Some people make a mistake in these problems. They'll only leave like 2 logarithms in the answer. They'll give it like 4x gets 1 log. No, log 4x is like log 4 plus log x. That's kind of a different example. But that's where people make mistakes. All right, so make sure you expand it into however many logarithms as there are factors, okay? The 4, the x, and the y. Add the coefficient, and every variable gets its own logarithms, all right? Example 3. So we've done now condensing to a single logarithm. We've done expanding. And one more, we'll do a solving problem and then call it quits. Solving equations is going to involve condensing into a single logarithm first. All right, so this is actually kind of an easy one. I think log base 3 of x minus log base 3 of x plus 3 equals -2. All right. It says solve the following equation using properties of logarithms. All right. So the move here, again, is to condense first. So we're going to condense this to a single logarithm. Because it's subtraction, we're going to divide the arguments. Okay? So just to remind you, this is an application of the second property. Log x minus log z is log of x over z. It's log of x over x plus 3. Now, to solve this equation, as you might remember from a recent set of problems, we're solving log equations. We want to write this exponentially. Okay? So when you're solving an equation, the instructions are to solve for x. You want to use the condensing properties, but then you got to use, then it becomes a problem like you know how to do. This means if log base 3 of this is -2, that just means 3 to the -2 is x over x plus 3. 3 to the -2 is 1 over 9. And now, because we have this circumstance, a fraction equals a fraction, we can just cross multiply. 1 times x plus 3 equals 9 times x. So 1 times x plus 3 is just x plus 3. If it was not 1, we would distribute it to both. And now, let's just take away x. We get 8x equals 3, and divide by 8. So x is 3/8. That's it. Okay? So just two problems where just we were condensing or expanding, and then one where we applied condensing to solve an equation. All right, so I'm going to give you guys a handful of problems with respect to condensing, expanding, and solving in class. Okay, probably some that are a little more basic than these, but the hope is that you see how the more challenging problems are done. Then maybe you can go back and do the more simple ones on your own. All right, take care.